Hello you guys, this is Sai and today we're going to be focusing on algebraic variables and expressions. Okay, so let's just dive into it. Right off the bat, you'll see that there are two really important vocab terms, variables and constant. Okay, now I can't even explain to you how important these two vocab terms are. You just really need to know them. Okay, so let's define them. A variable is a symbol, usually a letter, used to represent a value, used to represent a value that can change, that can change. Okay? Now let's look at some examples of what a variable would look like. So a variable can look like this: x, y, z, and the next three that I'm about to write, you will not see this in algebra. You'll start to see them more of in trigonometry and geometry. So don't really focus on it too much. However, just know that theta, alpha, and beta, they're symbols, meaning that it is still a variable. In algebra, you'll just see letters like these, primarily x, y, z. However, you can still see other variables like p. So don't worry too much about theta, alpha, beta, okay? Now let's define constant. A constant is a value that does not change. So basically a constant is just a number on its own. So for example, it is just a normal number. 3, 5, 9, so on and so forth. Okay, so it's just a number that's standing on its own, by itself. So let's just look over here. This expression, x would be a variable in this case, and 4 would be a constant. Okay, so as you can see, 4 is just by itself, it's just a constant, and x, it's a letter, therefore it is a variable. Let's just get this out of our way. Okay, now let us turn algebra into words. So over here we see x plus 4. Now you could say this as the sum of x and 4, or x increased by 4. Okay, notice how I have used the word sum here. Whenever you see sum, you just know that it is addition. Again, increased, addition. Okay, so these are some key terms that you just gotta know. Okay, now let's move on to z minus 8. So z minus 8 can be said as the difference. One second. Okay, the difference, again using that key term, difference of the variable z and the constant 8, or 8 less than z. Notice how I have said 8 less than z and not z less than 8. Z less than 8 would be like this. And this is not the same as what we're originally given. So just know how you use this. So again, using the key term less. So increased meaning addition, and the key term less meaning subtraction. Now how do we say 5 times y? We would say this just normally. 5 times y. You could also say this as the product of 5 and the variable y. Okay? Moving on to p divided by 3. So, to say this as p divided by 3, or the quotient, using that key term quotient, of p and 3. Okay, so again, let's point out some key terms that I've used here. Sum, increased. Okay, sum, increased, meaning addition. Difference, less, meaning subtraction. Times, product, meaning multiplication. Divided, quotient, meaning division. Okay, so you guys just need to, just remember these. Okay, moving on to words to algebra. So, how will we say 5 more than twice the number y? Okay, so I see that, it's 5 more than, meaning that you're adding 5 to something. Let's just not even worry about this right now. We know that 5 is going to be added to something because it says more. So 5 plus, now let's not worry about this, and let's look at this. So twice the number y. So twice meaning 2, and twice the number y meaning you're multiplying 2 by the variable y. We don't know what y is. All we're given is that it's just any number. That is what a variable is. It's just, you could replace y with any number. So we would say this as 5 plus 2y. That is our answer. Okay, so again, let's look at this one more time. So 5, you're adding, because it says more, twice the number y, meaning you're multiplying 2 to the variable. We don't know the number. We just know that it is any number. It could be any number. Twice the number y, meaning 2 is multiplied to y. Now, since we're here, since I have this right in front of me, I'm just going to quickly point out a important addition property called the commutative property of addition. So, what is the commutative property of addition? Let's quickly write that down. The commutative property. Now, what I'm about to tell you is not the answer for this. I'm just showing you another way just this itself can be written, okay? So disclaimer, it is not the answer. Here, let me just switch the color to gray, okay? So the commutative property says that 5 plus 2y is the same as 2y plus 5. So the reason why I'm going over this is that, just don't get confused because there's a variable that is multiplied to 2. It works same way, okay? So 5 plus 2y is the same thing as 2y plus 5. Moving on to 10 less than the quotient of 9 and the number x. Okay, so I see a lot of terms and numbers. So let's just break this down like we did with the first one. Let us just not look at this. Let's just focus on 10 less than. So we know that 10, something is going to be subtracted by 10. So we're going to leave a little space, and we don't know what's going to be over here, but we do know that whatever this is, whatever is going to be here is going to be subtracted by 10, okay? Now let's cross that out for a second and let's focus on the quotient of 9 and a number x. So, quotient. Let's come back to here. What did we say? The quotient is division, right? That's another way of saying that you're going to be dividing something to something. So the quotient of 9, meaning 9 is going to be on the numerator of our fraction, 9, and a number x, meaning x is going to be on our denominator. So what it is basically, in simple terms, it is just saying that 9 is divided to x, by x, my bad. So 9 divided by x minus 10 is our answer for this one. Now, the product of 8 and the sum of a number z and 5. So what this is saying is that I see product, meaning multiplication. So I know that 8 is going to be multiplied to something. And it's now saying the sum of a number z and 5. So before we fill the rest in, let's just go back and let's just quickly focus on this for a second. So we need to know how to write things in math. Now, that seems silly for even me to say, but we need to know that there are other ways to write 5 times y. So this dot in the middle is basically saying that 5 is multiplied to y. Okay, so one way of saying this is 5 dot y, so 5 times y. Commonly, you will more see that when you're multiplying a number to a variable, there will be nothing in the middle, okay? It'll just be combined like this. Now, don't get confused. If you're multiplying 2 by 3, for example, you can't just do this, okay? That turns into a number. So, but however, when you're multiplying a number to a variable, you could just join them together, okay? So 5y. You could also write this as 5 and a small x in the middle and y. So just remember, all of this is the same thing. It is saying the same thing, which is 5 times y. And then you could also write this with parentheses. So let me just quickly write that. Okay, so this is other ways you could write this. You will not really see this a lot, but you will really see this a lot. So just be aware of that. Now, moving on to where we were here. The product of 8 and the sum of a number z and 5. So now that we know what that means, let's focus on this. The sum of a number z and 5. So we know that 8 is being multiplied to something, so I'm just going to draw parentheses. Remember this? Right. So with this is how I envision my answer is going to look like. 8 times the sum of a number z and 5, meaning that z is added to 5. Z plus 5. And that is our answer. Okay, so what this is saying, now we're going to focus on these type of problems a lot more. And we're going to learn about fun stuff like distribution and all of that. But for right now, just know that 8 is being multiplied to z plus 5. So it is being multiplied to both z and 5. Now, let's look at a word problem type problem. Okay, so we're going to write this in algebra terms. Okay, so John reads 23 pages in an hour. Write an expression for the number of pages he can read in h hours. So we know that in 1 hour, John can read 23 pages, right? Because it says in an hour. In an hour. Now we know that if he reads 2 hours, he would read double the amount, which is 46. If he reads 3 hours, then it will be 23 times 3, which would be 69. So in 3 hours, he would read 69, and we could just do this on and on and on. However, there's an easier way of, writing this. We could use our variable. Now it says write it in h. Okay, so we could just do 23h, and this means that it can change, right? So this means that we could basically plug in any number at this variable h, and we would get the same output, meaning. So let's just box this answer and I'll show you how this works. So 23, we could plug in 1 for this h. So 23 times 1, and we will get 23 because we're just multiplying 23 by 1. Now 23, we could plug in 2 at this h value, at this h variable, I should say. 23 times 2, which would give you 46. So basically what we could do is that we could replace h with any number, 1, 2, 3, and so on and so forth. Okay? Just guys, make sure you know how to do all of this. It's pretty important. It's just, the foundations, the basic of algebra. Now, moving on to algebraic expressions. Okay, so let's just define substitution. Substitution is to replace a variable with a number. So I already kind of gave you an intro over here, okay, and how you could replace the number of hours as in 1, 2, 3, all of that for h, and you would get the same output, which is 23, 46, 69, blah, 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 okay? So what it's asking us to do is that we're supposed to evaluate the expression, okay? And it has given us a replacement set, 2, 4, and 5.7. Okay, so what it is basically asking us to do is that replace this x with numbers 2, 4, 5.7 individually. And I'll show you how to do this. Okay, so x plus 9. How do we do this? So let's just write down x plus 9 quickly. I'm going to use a different color to just show you different numbers that we're going to be plugging in to x. So 2 is the first number that we're going to be plugging in for x. So 2 plus 9, now we know this, it is 11, right? Let's write down x plus 9. Okay, now what the second number that it's asking us to plug in is 4. So 4 plus 9, and that would give us 13. And x plus 9, let's quickly write that. Okay, and the last number that we're going to be plugging in for x is 5.7. So 5.7 plus 9 would get us 14.7. Okay, now we could box these answers. So your 3 answers are these. So your answers are 11, 13, and 14.7. So yes, you do have 3 answers. Now let us tackle 1/3 v. So 1/3, this fraction is being multiplied to the variable v. Okay, so we're just doing the same thing. Okay, you guys, we're just doing the same thing. We're just plugging in 2 in v. So 1/3 times 2 would get us 2/3. Okay, just remember multiplying across. So 1/3 times 2 over 1 would just get us 2 times 1 over 3 times 1, and that is 2 over 3. Okay, so this is just basic multiplying fractions. Now we have 1/3 v, and now this time we're going to be plugging in 4. So 1/3 times 4, and that should get us 4/3. Okay, we're doing the same thing as we did over here for our previous part. Okay, and last but certainly not the least, 1/3 v, and this time we're going to be plugging in 5.7 for v, okay? And this should get us 5.7 over 3, and this is reduced to, or in decimal terms, this is 1.9. Okay, so these are your answers. 2/3, 4/3, 5.7, or 1.9. So let's just quickly write that out. 2/3, 4/3, and 5.7 over 3. Okay, so these are your answers. Okay, you guys, that is the end of that. Thank you so much. Bye.